Hey guys, this is Mr. Lee with another geometry video lesson. This lesson is found in section 1.5 of your textbook, and this is your introduction to everything about angles. Okay, so your learning objectives are you are going to be able to name angles, measure and classify angles, identify congruent angles, use the angle addition postulate, and bisect angles. I'm going to teach you how to bisect angles. I'm going to teach you all the constructions in the next video, but I'm going to teach you everything else about angles in this video. So angles are made up of two rays. So here we have a ray, and you remember how to name this ray. This is ray BA. B is the endpoint. Okay, and then there's another ray, and you see that there's ray BC. And ray BA and ray BC share a common endpoint, point B. And that common endpoint is their vertex. Okay, so point B is the vertex of this angle. And the two sides, side BA, the two sides are the two rays. Okay, so side BA and side BC. Okay, so naming angles. This angle, since it's the only angle on the page, okay, that we're concerned about, and it's very, clear that this is the only angle. If I say, hey guys, look at this angle, okay, it's clear that we're talking about this angle right here. We can call this angle B, okay, just like this. We can name it by its vertex, and we can just name it angle B, and you would just write that angle B, just like that, okay? The most common way, however, is to call it by 3 points, okay? 1 point on a side, the vertex, then another point on the other side. So this is the most common way to name and write the name of an angle. So this would be called angle ABC with no commas or anything like that, just angle ABC. Now, it doesn't matter if you call this angle ABC, you could also call it angle CBA. The only thing that matters when you're naming it with these three letters, or these 3 points, is the vertex must be the middle letter. Okay, the vertex must be the middle point. Okay, and then these two points, A and C, it doesn't matter if you go C first and then A, or A first and then C. That does not matter, but they have to be points on the two different sides of the angle. Okay, so angle ABC would be the same thing as angle CBA. Okay, then the third way, which is not very common at all, but sometimes you're going to have to do this, especially when there's many, many, many angles. When you get into these complex diagrams, when there's lots of angles, like 8 angles or something like that, sometimes the author will just simply number the angle, okay? And they're going to put the number inside the angle. This is called the interior, inside the angle. And it's clear that this number 1 is talking about this angle right here. So if the author does, or the illustrator does, go ahead and put in the number, okay, that means you can call this angle 1. Okay, and again, you wouldn't really do this unless there's many angles, and it's very unclear, as to which is which. The other thing that I don't want you to get confused about is sometimes there's going to be numbers inside of this angle, inside of an angle, and it'll say something like 30 degrees. Okay, that is not the name of the angle, that is the measure of the angle. And I'll talk more about that in just a moment. Okay, so here's 3 different ways to name an angle. Just by the vertex, angle B, and that is only if it's absolutely clear what we're talking about. There's no other angles, around it that can confuse us. The most common way is to name it by 3, okay, angle ABC or angle CBA, okay, and then less common, a number. Okay, so now let's move into angle measure, okay? So the angle measure is this, like how wide is this angle? Okay, how big the angle is. It's written as measure of angle ABC. So there's this little lowercase m right next to angle, the angle symbol. So this statement is read, the measure of angle ABC. Now, the measure of angle ABC is a number. Okay, it's a number. It is a number that represents this measurement right here. Okay, how wide is that angle? And our unit of measurement that we are going to use is degrees. We're going to use degrees throughout this entire course. Next year, when you get to Advanced Algebra 2, you're going to also learn about radians, and you're going to understand how to talk about angles in terms of radians. But for us, we're pretty much going to just stick to degrees. Okay. Remember that this symbol right here, the measure of an angle, is a quantity. It's a value. It is a number. Okay, so the measure of an angle is a number, and the angle itself is a shape. So please make sure that you remember that. Okay, numbers can be equal. Shapes cannot be equal. Shapes can be congruent. Okay. Okay, we have to remember classifying angles, and this is something you learned probably last year, or maybe a couple of years ago. Okay, if you have very sharp angles, small angles, and technically it's an angle between 0 and 90 degrees, okay, not including 0 and 90. Okay, if you have an angle that's greater than 0 and less than 90, it is an acute angle. Acute angle. It's very sharp. It's a small angle. Okay. If you have an angle that's exactly 90 degrees, that is called a right angle. And if you have an angle that is larger than 90 degrees, greater than 90 degrees, but less than 180 degrees, so between 90 and 180, that's a very large angle, very wide angle, that is called an obtuse angle. What if the angle is exactly 180 degrees? Okay, then we call that a straight angle. So these are the 4 classifications that we are going to deal with in this course. Okay, you also have to know how to use a protractor and how to read a protractor. Okay, we use a protractor. That's a tool to basically just measure an angle. Okay, and how do you do it? Well, you're going to place the protractor over the angle with a vertex. Now, there's lots of different kinds of protractors, but they all are going to have like a center point, like a dot or a hole or an X, okay, at the bottom middle of it. And you're going to place that center point over the vertex, okay, and then you're going to line up one of the sides, okay, maybe this side, line it up with the baseline that's on the protractor. And I'll give you a visual in just a second. Okay, and then you're just going to read where the other side intersects the protractor. Okay, and there's going to be numbers, 2 different directional numbers, depending on if you're measuring to the right or to the left. So here's a visual. So let's say we have this angle ABC, and I've colored the sides different colors just to make it easier to see. Okay, so we have angle ABC, and the question is, hey, can we measure this angle with our protractor? Yes, we can. So we just lay the protractor, and this is probably what most of your protractors look like. Okay, but again, there's many different types of protractors. But with this protractor, there's no hole here. There's just a cross. And so that cross is the center, and you put the center right on the vertex. Okay, your protractor might have a little hole there or a little dot. Okay, but line up one of these baselines, and I chose this baseline, and line it up exactly on this ray on one of the sides. And you can see I actually kind of missed a tiny bit. And if I was actually doing this by hand, I would be a lot more careful and a lot more meticulous. This is actually just computer user error because it was very difficult for me to overlay this and get it exactly right. I tried for quite a while, but imagine that this line, this blue line would just kind of disappear because this baseline would cover it up completely. Okay, then you would zero out this baseline. Okay, then you read where the other side goes through, and the other side goes through, and there's 2 numbers. There's 50 or 130. Well, which do you think this angle is, angle ABC? Would it be 50 degrees or would it measure 130 degrees? Well, obviously it's an acute angle, so it's going to be less than 90 degrees. So the 50 degrees is what we want to use. So the reason why there's two sets of numbers is because it's directional. So if I put my baseline on this side where the 0 is here, then I'm going to read the lower numbers going around this way. But if I had an angle that was going this way, again, I put my baseline on the 0 here, okay, and my other angle was going this way, I could read the upper numbers, okay. Also notice that this baseline is a straight angle, right? It's a 180-degree angle. So if you look at 50 and 130, they add up to 180. So those are supplementary angles. So that tells you that if I just extended this blue ray on and drew the opposite ray on this side, then the supplementary angle, this angle would be 130 degrees, and this angle is 50 degrees. Okay, I'll talk more about supplementary angles in a later lesson. So here's our first example. And the book will give you like a diagram that looks just like this. And this is like a classic textbook example. It's also, you're going to see this in the quizzes and probably on the final exam. And you're going to be asked to just read this particular diagram. Okay, and so we have all these different angles. There's 4 angles, 1, 2, 3, 4, but there's also many other angles, right? Like if I go angle PQT, angle PQS, angle Q, RQU. So there's many angles here. There's more than just 4 angles. Okay, there's overlapping angles as well. Okay, so be careful which ones you choose. So I like to actually put my finger on, and I don't, obviously this is digital, so I'm going to use my pointer, okay, my cursor. I'm going to put my cursor over and actually touch which points I'm looking at. So find the measure of each angle and classify this. So these are 2-part questions. We want to find the measure and we want to classify. Classify means tell whether it's acute, obtuse, right, or straight. Okay, so angle RQU. Okay, so actually go ahead, and it's a good practice just to touch the angles and these points. RQU. So I can automatically see that that is an obtuse angle. It's going to be greater than 90 degrees. Plus I know that this side is the 0. So here's 0, the 0 is on the lower. So I'm going to read these lower numbers. So this goes to 100, and then it goes through this point here, which is halfway between. So this is 125 degrees. Okay, so the measure of angle RQU is equal to 125 degrees, and it's obtuse. Now, this is the nomenclature. This is the proper notation. Okay, you're going to write measure of angle RQU equals 125 degrees. If you forget the degrees, it's wrong because this has a unit of measurement. Okay, so you have to have degrees. The most common student error that I see is some students will drop this M, they'll forget to write M, and they'll say angle RQU equals. Well, that statement is completely false. You cannot have a shape that equals a number, okay? So remember that shapes are congruent and numbers are equal. So you have to have measure of angle RQU. You have to have this M. Okay, if you do not have that M, it is wrong. It's a completely incorrect statement. Okay, so measure of angle RQU, this is a number, equals 125 degrees. Okay. Next, TQU. Again, actually physically with your finger, point to or touch the actual points. Okay, TQU. Okay, and I can see that that is a very sharp, very acute angle. Okay, now, this one does not have one of the sides on a 0. It's not been zeroed. So, well, what am I going to do? That's okay, not to worry. Okay, just look at the numbers, either the top or the bottom. It really doesn't matter, and then subtract. Okay, so I know that this ray QU, goes right through 125, halfway between 120 and 130. So on the lower numbers, it goes through 125. This ray goes through 90 on the lower numbers. So all you have to do is just do 125 minus 90. Okay, and that will give you your answer. And you'll find that measure of angle TQU is equal to 35 degrees, which is a very sharp angle. It is acute. Finally, angle UQS. UQS. Okay, same thing. We're going to use subtraction. So this on the top numbers, this looks like 145 degrees. On the top numbers, this is 55 degrees. So 145 minus 55 is equal to 90 degrees. So that's a right angle. Again, make sure, I can't stress it enough, make sure you have this little m if you're talking about the measure of an angle, okay? How wide an angle is. All right. Finally, we're going to learn about something called the angle addition postulate. The angle addition postulate. Remember the segment addition postulate. Okay, remember the segment addition postulate. The segment addition postulate was when we quote unquote add two segments, right? And segments are actually shapes, so you don't technically you're not adding the segments, you're adding the lengths of the segments. But because we're doing constructions with these, it's nice to just say that we're adding segments. And here we're sort of adding angles. Okay, so the angle addition postulate is the exact same thing as the segment addition postulate, except it's for angles. Okay. All right. So before I get into the angle addition postulate, the details of it, we have to define this thing called interior of an angle. So the interior of an angle is exactly what you think it is. It's very intuitive. It's the inside portion of the angle. So all these points, all these infinitely many points that are inside, okay, these are interior points. Then everything else out here would be the exterior. Okay, and that's important because when we talk about angle addition postulate, we're going to use this interior point. Okay, so here is the textbook definition. If P, point P, which is the point right here, if P is in the interior of angle ABC, then the measure of angle ABC, so that measure, okay, that measure is equal to the measure of angle ABC. This is wrong, sorry. This should say the measure of angle ABP. I will correct that, sorry. Plus the measure of angle CBP. Okay, so this red angle, the measure of this red angle plus the measure of this blue angle equals the measure of the black angle. Okay, so this black piece, okay, so the entire angle is broken up into these two smaller angles. And I apologize for this. That's typographical error. I will correct that. Okay, so the black measure is equal to the red measure plus the blue measure. Okay, in other words, the biggest angle is equal to, and again, I'm using my words not very carefully, but this biggest angle, angle ABC, is sort of comprised of these two smaller adjacent angles that are inside of it. Okay, so if we're given that this angle measures 23 degrees, okay, this red measure is 23 degrees, and if we're also given that this blue angle measures, let's say 26 degrees, can we calculate the measure of angle ABC, this black arc there? Yes, we can. Well, we know that the measure of angle ABC is equal to 23 degrees plus 26 degrees, and so the measure of angle ABC is equal to 49 degrees. Next example. Okay, given that the measure of angle LKN, again, let's point to the actual things, LKN. Now you can see that that is a very obtuse angle. That's a very large angle. Okay, given that that angle measures 145 degrees, then find the measure of these two interior angles. Okay, angle LKM, LKM. So we want to find this measure, and angle MKN, MKN. So we want to find this measure as well. Okay, so how are we going to do that? First of all, do these two angles look like they're congruent to each other? No, we can see that this angle looks much larger than this angle. Okay, so we don't know that they're congruent. So these two expressions are not equal to each other. But what do we know? These two expressions add up to this total right here, which is 145 degrees, which we're given, okay? So let's go ahead and set up our equation, and let's first solve for x. Then we're just going to plug x in or substitute x in into each one of these expressions to find the measure of those angles. Okay, so angle addition postulate tells us this: measure of angle LKN is equal to measure of angle LKM plus the measure of angle MKN. Okay, now we just substitute in the values that were given. 145 degrees equals 2x plus 10. This 2x plus 10 is this 2x plus 10 right here, plus 4x minus 3, which is this 4x minus 3. So these two blue expressions added together, give you the 145 degrees. Okay, so now this is just straight algebra, solve for x. Okay, so let's combine some like terms. So combining like terms, we see on the right side of the equation, we see that 145 equals 6x plus 7. Let's subtract 7 from both sides of the equation. Now let's divide by 6 to find that x equals 23. Okay, now, are we done? No. Okay, now be careful, because in algebra, what did you do? You would solve. When you solved for x, boom, you're done. Go on to the next question. Okay, do not do that in geometry. Go back and read the question and see if we've answered the question. We have not answered the question yet, because the question says find the measure of angle LKM and the measure of angle MKN. So now we have a few more steps to go. Let's go ahead. We found that 23 equals x. So we're going to go ahead and substitute that into each expression one at a time. Okay, so we just substituted in the 23 for the x. Okay, so that's 46 plus 10, which is equal to 56 degrees. Now go back and look at the diagram and just kind of make sure it sort of makes sense. Okay, so 56 degrees, we know that's less than 90. It's acute. Yeah, that looks like an acute, okay, like an acute angle. That looks about right. Okay, this angle, if we were to predict what this is, that looks, pretty close to 90 degrees. Does that mean it's 90 degrees? No. Okay, we don't know. It could be 89, it could be 88, it could be 92. Who knows, right? We cannot assume that just because an angle looks like it's 90 degrees, we can't assume that it's 90 degrees unless it has a little right angle mark in here. Okay, so two ways we can solve for this. If this work is correct, we could just say, well, this must be 145 minus 56. Okay, but let's do it the long way. Let's just plug 23 back into x into this expression. Okay, so plugging 23 in, we see it's 92 minus 3. We see it's 89 degrees. And you see that? So be careful. Just because an angle looks like a right angle doesn't mean it's exactly a right angle. Okay, this one's close, but it's 89 degrees. And then just, check your work. Make sure that 89 plus 56 equals 145, which it does. So we're good. Okay, this is I think I said the last thing was the last one, but this is actually the last topic for this video lesson. Then again, I'm going to go back and do another lesson after this and teach you how to do the constructions of all these things. But in this lesson, we're going to talk about bisecting angles. So do you remember when we learned the construction on bisecting a segment? Okay, constructing a segment bisector, and we ended up making a perpendicular bisector. Okay, super cool. It was the football construction, right? Well, what is a bisector? What was a segment bisector? A segment bisector was something, could be a line, it could be a ray, it could be, whatever. It's something that goes through the midpoint of a segment. And basically what it is, in layman's terms, it's something that cuts a segment exactly in half, right? It cuts it in half. So to bisect means to cut something in half, right? So you have two now congruent parts. So bisecting an angle, we're now going to cut an angle in half, and we're going to end up with two congruent angles, okay, that are each one's measure is half the measure of the biggest angle that we started with. Okay, so here we go. So here we have a diagram. We have this big blue angle XYZ, and in the interior of this angle, we have ray YW. Okay, and we see that these two green marks, these are angle congruence marks. Okay, these arcs are angle congruence marks. Okay, so green and green, that means that these two angles are congruent. Okay, these two angles are congruent. So that means that this red ray YW, is indeed a bisector of this blue angle. It's an angle bisector. Okay, so an angle bisector, here's the textbook definition. An angle bisector is a ray that divides an angle into two angles that are congruent. In this figure, ray YW bisects the big blue angle, angle XYZ, such that angle XYW, this angle is congruent, okay, congruent to angle ZYW, okay, congruent. Notice they used congruent because shapes are congruent, okay? Numbers or quantities are equal, but shapes are congruent. So later in the next video, I'm going to actually show you how to actually construct this. It's actually a super cool construction. Because we're going to cut an angle exactly in half. It doesn't matter how big the original angle is. We know how to bisect it. It's going to be super fun. Okay, so here's our third example. So we are given this information up here. We're given that ray QS bisects angle PQR, and we're also given that the measure of angle PQS is equal to 24 degrees. Can we find the measure of angle PQR? PQR. Okay, so that's the biggest angle, okay, that we can see. So because this ray bisects this big angle, we know that these two angles, these two smaller interior angles, are congruent. And if the angles are congruent, we know that their measures are equal. Okay, so this is, again, a very easy example. But what I really want you to stress on with this example is the notation. Because remember, notation is just as important as the concept, right? You have to learn the language of the discipline, not just the concepts. Okay. So we know that because we have a bisector, we know that angle PQS is congruent. Notice it's congruent, not equals, is congruent to angle SQR. Okay, and because those two angles are congruent, now we can conclude that their measures are equal. So the measure of angle PQS is equal to the measure of angle SQR. So this statement, compare it to this statement, it's almost identical, except now I have measures in front, which makes these numbers. And so I replaced the congruent sign for shapes. I replaced it with the equal sign because these are now numbers. Okay. All right, so now let's just go ahead and substitute in some values. We know that the measure of angle SQR has to also be 24 degrees. Since this is 24 degrees and this is equal to it, well, this must also be 24 degrees. What else do we know? Also, we know, because of the angle addition postulate, we know that the measure of angle PQR, this big measure, is equal to the sum of these two smaller measures. So substituting in the values, we know 24 degrees plus 24 degrees is equal to 48 degrees. Now just go back and look at your diagram, make sure that makes sense. PQR, yeah, looks like it measures about 48 degrees, right? Okay. So now it's time for you to practice. So there are the next two assignments. That's lesson 12 and lesson 13. Okay, it's on page 43 and 44. Enjoy, and in the next video, we'll learn how to do these constructions for angles. It'll be a lot of fun. Thanks, guys.